So hey guys, welcome back to my channel. So in this today's video, I'm going to explain you all the write-ups of reverse engineering challenges. Okay, so this CTF event was conducted by LakshyaCTF. Okay, so this both reverse engineering challenges were much fun. Okay, so the first one was very easy. As you all can see, there are many solves for this, 67 solves, and the second one was like bit easy to medium challenge. So there are 25 subs. So most of you all have asked me, how I solved this challenge. Okay. So in this video, I'll going to explain you all the both of the challenges. Okay. In detail. So how I exploited it, or basically how I solved it and got the plug. So let's move to our virtual machine over here. So I've created the two folders, challenge 1 and challenge 2. So challenge 1 consists the first challenge and this consists the second challenge. So first we'll open this file. So first one was hello.exe. So I'll just develop it and see. So it does nothing, right? So I'll just open my terminal over here and just try to run that hello.exe. So it just prints out with the hello world. Okay. So now the first thing is that while doing any kind of reverse engineering on particular file, okay, so what we need to do is that we need to check some, metadata or information of that file. Like there is a tool called as DI. So it is called as Detect It Easy. So I've already downloaded that tool over here. My this. So I'll just open this. Then I'll browse my file. Desktop, challenge 1, hello. Then click it on open. So it will going to do all the analysis over here, and then it has here detected it as language C. So it is compiled in C language and it is P32, so portable executable format, right? So it is compiled in C. So what we can do is that now, if you want, you can extract the strings. Okay, so there is a command strings.exe on hello.exe. So it will going to extract all the strings from that primary. So sometimes there might be a flag, okay, hidden inside or hard coded into that particular binary. So what we'll do is that we'll just redirect this output to a file called as str.txt. Okay. So now we have this. So I'll open this into my Notepad++, and then I'll just check it for LakshyaCTF. So as of now, I can't see the flag. Okay. So now what I'll do is that I'll open this particular binary into a decompiler. So I'll use the IDA64 for this, and then click on this hello.exe, which I've already, loaded it by solving the CTF. So just double click on it. Click OK. So that will going to do the minimal analysis on it. So now, as we can see, the function graph over here. So it is just calling a print hello function. So now if you see on this function tab, okay, over here, we can see there are some function called as main, hidden flag, and print hello. So print hello basically prints the hello world on top of the stack, and then it loads it into the buffer, and then it prints out to the footer. So there is one more function over here, okay, so it is called as the hidden flag. So I'll just double click on it, and as we can see, there is a flag over here, which is hard coded onto the stack. So it is LakshyaCTF hidden underscore flag here. So this is the first flag for this. So now there are many other ways to patch it. Okay, so now I'll also show you all the patching work, how we can also do. Okay, so there is one more tool called as binary ninja. So what we need to do is that we need to come into the main function over here, and instead of calling to the print hello, we can directly call the hidden flag address. So it will directly print with the hidden flag. Okay, over here. You can also do that. But it's very easy, just to copy this whole thing and just do some stuffs and sorting everything, and then we'll get the plan. So this was the first challenge, hello.exe. So now I'll move to second challenge. Okay. So the second challenge was, I'll close these two. I'll come to the second challenge, right? So the second challenge was RE. Okay. So now what I'll do is that I'll just double click on this, and then we can see a pop-up, right? A window. So it basically asks us some, input. So let's suppose we put like please sub, and I click on submit. So it says invalid key providing. So if I enter some 1 2 3 4 or some gibberish, so it says me invalid key providing. So now we can see that this is some, so if you all are having some experience in, creating Windows Forms apps and all by using Microsoft Visual Code, so Visual Studio Code. Sorry for that, yeah. So this is coded into that language. So it is coded into the C sharp language for it, right? So now what I'll do is that I'll just close this, and I'll try to open the die tool, the detected easy tool. Okay, and then I'll load that binary again into this. Okay, I'll go to my desktop, settings to re1.exe. Yeah, so it will do the analysis on that. So it will going to check whether it is a pack binary, what packer has been used for all the analysis it will do. So we'll wait for that. Yeah, so as we can see, it is a P64-bit. Okay, so portable and disputable 64-bit format, and it is compiled into C++ using Microsoft Visual C++ compiler version is given, and they have used a tool for Visual Studio 2019. Okay, and the library which they have used is .NET Core Loader. Okay, so this will be very helpful for us, for making analysis that this particular binary is running something related to the C sharp. Okay, so now what we'll do is that we'll just try to open this into IDA. Okay, I'll just open this. So I already opened this over here, re1.exe. So I'll just double click on that, and then yeah, click it to default. Root is again. Yeah. So just click it on S. So he finds out the PDB files and all, okay, the symbol files. So just click it on S. So it will going to download the necessary symbols from that particular binary. And now if you see, this is like, a totally junk type. Okay. So in this analysis, we'll see out and look out for the main function, first of all. So it is taking a bit time because it is a very large binary. Yeah, it's done now. So I'll just click it on view, subviews, generate pseudocode. So it is, good for readability. So it is so this is calling the main function, and this is doing something called as trace setup, briefs, info, and printing or loading some particular hash. And as you can see over here, it is calling a function called exe start. And if you see over here, in the functions tab, wait a second. Yeah. So we can see the main function exe start is exe enabled. So for execution. So these are two functions. Maybe it is trying to load some dynamic code into memory which is based on C sharp and then executing it. Okay, because I can't see any form of the input like for an example we saw over here. So if I double click this, so the encryption challenge, the input box summit. So I can't see any type of packet over. So the next part which I moved on is that doing the dynamic analysis. Okay. So for that, I used a tool called Procmon. Okay, Procmon 64.exe, because it is a 64-bit binary, right? So just click on this. You don't, yes, yeah. And now over here you need to give the what we call a filter. Okay, so I gave this filter already, so it had come over here. So you all can select architecture if you all want, but it will going to give you all these junk files which are running currently into the system, right? So just click it on the process name, okay, and the process name is, and the name of your file, which is re.exe or re1.txt, right? And then click it on include. Okay, so I already have it re.exe. Just click it on OK. So it is now live. So the current filter is going live. So as soon as I uh, run this re.exe, it will going to pop up and show me all the processes or the sub processes which that process includes, okay, into that process. So I'll just rename this to RE because the filter should work, right? So as soon as I click, I'll leave this open, okay? So as we can see in this process monitor over here, so it states that the process has been thread created and loading the image of re.exe, okay? So now as we see, it is doing something with registry key and also, okay, so we don't need to focus on that. So these are all system dependencies, interaction between that code and all. So we need to see something which is which we can find it very easy to view. So as I scroll down to see, there is nothing much to view over here. But as soon as we come to this directory, the local temp directory over here, you can see there is a particular file been loaded called as re.dll. So re.dll, it might consist the actual code, okay, the actual C# code which is trying to execute this particular window over here, okay. So now it is located at this particular directory. So it uses Pratham update local temp.net and the name of the particular process RE and some weird characteristic the name and the particular DL. So if I copy this, click it on properties, I'll go with this, okay. Open my one more file manager and give this. So as I can see, there are many other DLLs also being loaded over here, but the main DLL will be re.dll because this contains the actual code, and you all can even check through the size file. So it is only 6 kilobytes, and these other files are the actual system files which we need to emulate the .NET code. Okay, so our main target is to decompile this file. Okay, so now we know that it is compiled into the C#. Okay, by looking at this UI, the Windows Form app UI, right? So what I'll do is that there are many tools available to decompile the C# DLL and the codes. Okay, so the first tool which I like to use is this Spine. If you want, you can use a DNSpy or .fake. Okay, so I'll just click on this and then I already loaded this DL, but I'll for your content I'll just try to remove this now, and again I'll try to open that file. Okay, so file, open, directory. I'll give the re.dll. Okay, so I'll click it on open. So as we can see, it is a .NET Core app version 5.0. So I'll just click on this, and then we can see the metadata, references, and some Windows form app. So if you all have done something decompiling related to .NET, then related to .NET binaries and all. So this will be very easy for you. So I'll just click it on Windows form app, and then click on this and the main form app. So as you can see, the main class, the main form, right? And then we can see the encrypted flag. Okay, so this, so that means we are almost done with this challenge. So I'll just click uh, the inform. So it is setting up the text, the de-encryption challenge, okay, over here, and the box with height and all the UI stuffs. Main thing is over here, de-encrypt. So as soon as we click on this button submit dot click, it checks and calls the de-encrypt flag function with the text or the key which we provide. Right? And then if you'll have some experience by looking at this code, you can see it is doing something related to the JOR operations. So, and then if that particular key matches, okay, this particular string where it is de-encrypted, and if that string matches the actual string, it will going to print as this flag. So the flag is nothing but LakshyaCTF super secret key. That's all. Okay, because it is directly returning the whole string to that particular text form. So I give this. So now for that to get this particular flag, we need to give the actual key, right? So what I did was that the time was very less, so I got down to the chat GPT and just copy pasted the code and decompile it. Okay, so I'll show you all the code, the actual key, right? So file, open, and then ff dot. So as of you all can see over here, it is the same file. The encrypted flag, it is showing over here. Target is my actual flag. So even if you copy this and submit or uh onto that flag input, it will take. So you all get the points over here. And then it is first trying to decode it to base 64 decode, and then it is trying to XOR it with the targeted bytes, which is LakshyaCTF super secret key. Okay, and then it will print me the actual recovery key. So I'll put it on run. So the actual key was the CTF key. If I copy this and come over here, and if I put it on CTF can submit, I get the flag Lakshya super secret key. So that's was how I solved this challenge, and by using my some sort of the minimal or the beginner malware analysis skills which you all need to solve this challenge. Well, this CTF event was really great, and I liked it, and I really like this challenge. Okay, it was really good by doing the dynamic analysis and getting the DLR during the runtime and then extracting it into the LNSPY. So it was really an amazing challenge. So yeah, so this was for the today's video, guys. So yeah, take care. Bye bye.